So our last video was all about finding the instantaneous rate of change. So for example, at the 18-second mark, at what rate is the pilot descending? Now, of course, everything we do in maths, we can generally do it in reverse. So if we know the rate of change, we can find out when that rate of change is taking place. So the question might be, is the pilot ascending at 100 meters per second? In other words, when is the gradient of this function 100? So if we need to know when the gradient is 100, first we need to know what the gradient function is. So simple derivative stuff here, f dash x is equal to 12x squared minus 400x plus 2500. And we're saying when is the gradient, which is the gradient here, equal to 100. So now we can just sub 100 for f dash x. 100 equals 12x squared minus 400x plus 2500. Now this is a quadratic equation, so if I take that 100 and subtract it from both sides, I'll get 0 equals 12x squared minus 400x plus 2400. And I can solve that using negative b plus or minus the square root of b squared minus 4ac over 2a, or I can solve it using my graphics calculator, or I can solve it using completing the square. In any case, my two answers for x are 7.847 or 25.486. So what we're saying is the rate, he is ascending at 100 meters per second at 25.48, which is just here. So it's just after he's bottomed out and he's just starting to ascend again. So it's not quite the turning point because obviously he's not ascending at 0. And the other point at which he's ascending is 7.8 something, 7.847. All right, so that means the gradient at that point is 100 meters per second, and also the gradient at that point is 100 meters per second. Now, that's not the only type of question you might get. You might also be asked sort of the follow-up, which is, what height is the pilot when he is ascending at 100 meters per second? So we've just found out that by subbing it into the gradient function, we've found out that he is ascending at 100 meters per second at 7.847 seconds and 25.486 seconds. To find out how high he was when that was happening, we have to sub these values in for x into the original function. The mistake a lot of people make here is they sub it into the gradient function, but we need to sub it into the original function because the original function tells us the height, which is what that is. So we sub both of them in. So we do f of 7.847 is equal to 4 bracket 7.847 cubed minus 200 7.847 squared plus 2500 7.847 plus 2000. And when I type that into my calculator, I will get 11,235.15 meters, which looks about right. And obviously, I'm not going to write all this one out for you, but f of 25.486 is the other time. Sub 25.486 into there, and there, and we'll get a second answer of 2024.08 meters. That's happening right there. All right, so there's your sort of second version there. You just need to be really careful about and mindful of where you're subbing values in and why you're subbing them in. I'm subbing 100 in here because I knew the rate of change was 100, so that's f dash of x. And then I'm subbing 7.847 for x into the original function because I want to know the original y value, not the rate of change. All right.